Well, hello and welcome back. So today it's the third day of December. That means the third day of Advent of Code. So let's just jump into it. Advent of Code. The third day's puzzle. So it's about rucksack reorganization. Interesting. One elf has the important job of loading all the rucksacks with supplies. So I guess rucksack is a link to Wikipedia. Rucksack means backpack, I think. Yeah, it looks like it. Job of loading all the rucksacks with the supplies for the jungle journey. Unfortunately, that elf didn't quite follow the packing instructions, and so a few items now need to be rearranged. Each rucksack has two large compartments. All items of a given type are meant to go into exactly one of the two compartments. Okay. The elf that did the packing failed to follow this rule for exactly one item type per rucksack. Okay. The elves have made a list of all the items currently in each rucksack, your puzzle input, but they need your help finding the errors. Every item type is identified by a single lowercase or uppercase letter, that is lowercase a and uppercase a refer to different types of items. The list of items for each rucksack is given as characters all in a single line. A given rucksack always has the same number of items in each of its two compartments. A given rucksack always has the same number of items in each of its two compartments. Okay, so it's kind of two same-sized compartments. So the first half of the characters represent items in the first compartment, while the second half of the characters represent items in the second compartment. Okay, so I guess when you have a line like this, you have to split it in half, and half of them will be items in the first compartment, and the second half will be the items on the second compartment. For example, suppose you have the following list of contents from 6 rucksacks. So this is the list. The first rucksack contains the items VJ blah blah blah, which means its first compartment contains the items VJR blah blah, while the second compartment contains the items HCS blah blah blah. The only item type that appears in both compartments is lowercase p. The second rucksack compartment is, well, same thing. The only item type that appears in both compartments is uppercase L, and so on, I guess. So it's always one item shared between the two compartments in each rucksack. Okay. To help prioritize item rearrangement, every item type can be converted to a priority. Okay. Lowercase items, item types A through Z have priorities 1 through 26, and uppercase items types A through Z have priorities 27 through 52. In the above example, the priority of the item type that appears in both compartments of each rucksack, oh man, all this terminology, is 16 for P, 38 for L, and blah 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 blah. The sum of this is 157. Find the item type that appears in both compartments of each rucksack. What is the sum of the properties of those item types? What is the sum of the priorities of those item types? Okay, so it seems like it's a common theme that we have to calculate something for each line of input and then sum everything up. I think the previous 2 days were also something like that, right? So let's open the Advent of Code projects. We are gonna create a new file for day 3. Press. Yeah, and we're also going to copy these sample inputs. and we're going to paste it here. Oops. In file, day free txt, and we're gonna do a public fun run, and we're gonna use the std_fs. Always know those short names. fs read to string, and I noticed that when I have that, like the Rust language server, and I save it correctly, like indents everything to four spaces, but it's like VS Code doesn't know this, and so it paints this line on 2 spaces. But I think if I reload, like if I close this file and I reload it, yeah, now it's fine. So I don't know, some hiccup by VS Code. So we're going to read into string the inputs day3 txt and unwrap that thing. Let's say that this is the inputs. Okay, so how are we going to do this? I think should we parse everything first and then process the contents? I mean, I do like to do that for sort of code organization matters, but I feel like in these first puzzles that are pretty simple, it's not really worth it. It's like maybe I can just iterate this line by line and like process things while I'm parsing the file, I think. So let's do exactly that. Yeah, we have to calculate the sum of the priorities of all those things. So let's say, like, let's priority sum is inputs lines. We're going to map each of those lines and sum them into something. And this is going to be, again, U32, because why not? So we are going to iterate over each line. And then what are we going to do? We need to get the two, like, split these item types in half for the first compartment and the second compartment. And I think I could use I could use slicing, and line here is a string, or where string slice. Oh, I think the language server doesn't pick up like errors or anything on this file, so it's not telling me like the types of things or anything, because I didn't import this from main. So it's like it doesn't exist, you know, until we do something with it. And now it correctly complains about map not doing something. So I guess we can say, hey, return 0, and it stops complaining. But I don't like that. The auto formatter, like, you see, if I save here, the auto formatter gets rid of everything, even the braces. So I don't. Sometimes I don't enjoy the auto formatting on save, but usually it's nice. So we are going to get the priority sum, and we are going to println it. Let's say priority sum. That should be the first answer to the first part. So how do we compute this? As I was saying, maybe I could get the line, which is a string, and convert it into a slice, which we can do to like a slice of bytes or characters. We could say this is the rucksack. How is rucksack spelled? Well, I didn't know. It is both times with K, C and K. Interesting. So rucksack items is going to be line as bytes. And then we will have the first compartment items is gonna be rucksack items. Is there like a split or something? Split at index? Yeah. The first item, first part will contain. So this gives us two sub slices. Nice. And the first part will contain all indices from 0 to the middle, not including that. Okay, so you have to pass the naming of that middle thing. Makes me think of like, is there something to put in half? No, I think well, so split. Then add rucksack items size, right? Divided by 2. I think that should. Is it not size? It is len, I think. Yes, and this is complaining because oh no, it was split at, I think. At. Yep. No, this thing, so this should return both compartments, I think. Yes, so it's gonna be a tuple which we can destructure here. So let's say first compartment and second compartment. Yeah, and now we have to find the item that is in both compartments. So can we do first compartment intersect or something? No. Or intersect, intersperse. Oh, nice. So there's an intersperse function. Those ones are quite nice. I think more than once I wish to have some function like that in JavaScript. So these are the functions that like put an item between each of the items in an array, or in this case in an iterator. So for instance, the typical thing of joining an array with commas or things like that. But there doesn't seem to be an intersect. I don't know if there is a standard collections set or something like that. There's a hash set. Yeah, maybe we could use that. Have two sets and make the intersection, right? Or maybe a simple loop would be enough. Let's use the collections. std collections hash set. Yes. And okay, so we have this too. Well, hash set from. Is it from or new? Yeah, it is from. First compartments. Maybe we could call this this is going to be first set. And let's do a second set. So this is complaining because I cannot manage to see the error when I have my face over there, cargo running. So what do you need? Do you need to be a reference or dereference this thing? Probably not. And probably let's look for it. Rust hash set from slice or from a vector, blah blah. Maybe I can do the simple loop. Victim, clone, drain. Interesting names. Why do you need to clone stuff? I don't feel like you should need to. I guess we could do something like from iter and first compartment iter. So this is going to be a set of references to interesting. But if we pass a cloning iterator, it's going to be a hash set of bytes. I feel like this is a bit too much. Let's try a simple loop. So for item type in first compartment, let's do we will need like a variable to hold this thing. Let's how does the instructions or the puzzle call this thing, like common item? The only item type that appears in both compartments, but shared item type, I guess, could be shared item type, and let's say a sentinel value of 0. And here let's do let's say if the second compartment contains the item type, then the shared item type is going to be this one, and we can break. And what is this? This is a reference to this. Fine, we can copy that, no problem. This should be mutable. And this is complaining because we are never reading it. Fine, we're gonna read it now. So we have to convert this shared item type to a priority. So I guess I could make this like an optional byte and then only set it there and then assert that there is a shared thing. But I mean, these are all letters, so none of them should be 0, like a null byte. So maybe we can assert that shared item type is not 0. Yes, and say there should be a shared item type between the compartments. Okay, yeah. Between compartments? Yeah, I didn't want to have such a long assert line. Let's close this thing. So what follows? I have to convert this to priority. So let's say priority. It's a difficult word for me to write or to say. How do we calculate the priority for this? I guess we have to match on the item or the shared item type. And if it goes, so these are bytes. So if it goes from A to Z, is this okay? If it goes from A to Z, it's gonna be, how do you say this? Like 1 plus this shared item type minus. So we get the shared item type. We should subtract, I guess, the A. So if it is A, like this subtraction will be 0 if the shared item type was B, and if it if it was A, and if it is B, it's going to be 1, and so on. So we have to add 1 to this. And then we would say the same, but for the uppercase cases. I'm sure there's probably a better way to do this, but I'm okay with that. And if it is anything else, I think we should error out. So this should be unreachable. And we can say invalid item type, and let's have good error messages, and this should be the shared item type. Although I would like to print this. This is going to be a byte, so I don't know if, well, we can just print the number. What is this? Exclusive range syntax pattern is experimental. See, oh, right. I'm using an experimental function. Is this exclusive? So I have to be inclusive, I think. Yeah, okay. The syntax for inclusive ranges is that. I had forgotten, but thanks Rust for the nice error messages. I didn't remember that when you say like dot it doesn't include the end of the range, but in this case we really want to include the sets. So okay, we have the priority, and I think that should be it, right? Priority. What are you complaining about? Priority is a U8, okay. And nice error message. The trait bound U32 is not satisfied with. Okay, do I have to say here, like, sum this into U32? No. So are you complaining because priority is not of the correct type? Can I say U32 here? Yes, now it doesn't complain. So I guess we could get the priority, which I think a single byte, single byte should be able to hold the priority, but transform it to U32 in there. Let's remove this. Yes, no more complaints. Cargo run. 105. Was that the correct answer? No, it wasn't. So we screwed it up at some point. Let's do some println, debugging println, and let's say the priority. No. Okay, it starts with 16. Yeah, that's correct. Then 12. No, it's not 12. Because that's an uppercase letter. We shouldn't be adding 1. It doesn't start from 1. These other ones start from 27. That's right. So how about now? 157. That's exactly what we want. So we can get the actual input, which is a whole lot of rucksacks. So there's a bunch of elves in this expedition. That's impressive. So we can run now, and it is, well, it should be this answer. We can also get rid of the no, this is day 2. We can close the other days. Whoops, we can go to day 3. Day 3, and remove this print line and submit this, and let's see if it works. And it did. Nice. So we go into part 2. Time for another mate. So, part 2. As you finish identifying the misplaced items, the elves come to you with another issue. For safety, the elves are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency, within each group of 3 elves, the badge is the only item type carried by all 3 elves. The only item type carried by all 3 elves. Okay. That is, if a group's badge is item type B, then all 3 elves will have item B somewhere in their rucksacks, and at most 2 of the elves will be carrying any other, item type. With what? That is, if a group's badge is the item type B, then all 3 elves will have item B somewhere in their rucksacks, and at most 2 of the elves will be carrying any other item type. I didn't really follow that one. Like this, the second part. Okay, the problem is that someone forgot to put this year's updated authenticity sticker on the badges. What? All of the badges need to be pulled out of the rucksacks so the new authenticity stickers can be attached. Additionally, nobody wrote down which item type corresponds to each group's badges. Okay, the only way to tell which item type is the right one is by finding the one item type that is common between all 3 elves. Okay. Every set of 3 lines in your list corresponds to a single. Every set of 3 lines in your list corresponds to a single group, but each group can have a different badge item type. So, in the above example, the first group's rucksacks are the first 3 lines, these 3, and the second group's rucksacks are the next 3 lines, these 3. In the first group, the only item type that appears in all 3 rucksacks is lowercase r. Okay. This must be their badges. In the second group, their badge item type must be Z. Okay. Priorities for these items must still be found to organize their sticker attachment efforts. Here they are 18 for the first group and 52 for the second group. The sum of this is 70. Okay, find the item type that corresponds to the badges of each 3 elf group. What is the sum of the priorities of those item types? Oh, this is a mouthful of a second part, but I think I got the gist. So before we were doing like intersection between 2 halves of 1 line, and now we have to do intersection between 3 lines, I think. But basically the same thing, I think. Yeah, it feels to me that should be it. But we were not doing the full intersection because we wrote it down as a simple loop. So I think we will need some more interesting logic here. So okay, let's first do something like not try to reuse the first part. I mean, we can use this, we will surely use this priority calculation, that is fine, but not anything else, I think. I don't know why this Rust language server thingy or Rust extension says, yeah, this is the function run, like what's the purpose of this? But anyway, what do we have to do now? Can we do something like input lines and then iterate every 3 of them? Tuple, like every lines group, something? No. Well, maybe I can type input correctly, right? Lines every tuple max by advance partition blah blah. There's okay, let's ask Google as I usually do. Rust iterator iterate over each 3 items. I don't know if that's no. What is it that? How is this concept called? Chunk? Iterate over every 3 item chunks windows for iterators. Okay, yes. Oh, there's an in Rust there is an itertools trait that provides a lot of utility functions for iterators, but I don't want to include external crates if possible. So there are chunks here in std slice, it seems. Chunks. Huh. Oh, but it is for slice. Isn't there chunks for iterators? Next chunk. Advances. Sorry, my face is distracting me here. Next chunk advances the iterator and returns an array containing the next n values. Okay, let's leave my face where it was, somewhere there. I mean, I guess I could also do like a simple loop with a get the lines and do a while loop, like do next 3 times, and then we'll have the 3 rucksacks. But if I can, I would prefer to have something like cleaner. There is, of course, a tuples for itertools. There is array chunks, but this is only in Nightly. Interesting. Unstable. Constant, what the hell? Okay, there's a bunch of things, and I think I am already like if there is no, maybe I can try with this Nightly thingy. Array chunks is called, but if not, then I can do something silly like dumber code, but be okay. Array chunks. Are you okay with this? What do you receive? Array chunks 3. An iterator over n elements of the iterator at a time. The chunks that do not overlap, blah blah. Okay, so I think this is fine. We are going to then map this into something, and then we are going to sum. We can say map them into 0, just to have something, and then sum. And here is going to be, well, we call this priority sum, but this was more like, what? Like shared items priority sum. And this is more like group badges priority sum or something like that. And this should be also should have a type, and it we should print it. Println. Group badges priority sum. Okay. So, what don't you like about this? Unstable library. Yes. Can you? No. Let's do. Well, I didn't want to do that, although maybe I did. Actually, I can collapse that and have more space for the error messages that I cannot read. Sometimes not read with my face there. So. Array chunks, why are you not happy now? Use just a little recently added, C should blah blah. Take 0 arguments, but 1 argument was supplied. Okay, so it doesn't take arguments. So the n is something that is a type argument. Can I pass it like this? Turbofish operator to the rescue? And now what do you complain about? Use of unstable library feature. Yeah, but I mean, I told you to use that. And then map. Yes, you can take an argument here. Why are you complaining though? Should be in the root module. Okay, so this should be in main, I guess. What do you complain about? Used in the stable release channel. Okay. Can I do something? I can remove this from here. Can't you just suggest what to do about this? Like, I don't know what a stable release channel is, but I'm losing a bit of patience over this. But let's Google the error. Rust this thing. What should I do? Install nightly. Okay. Do I want to install Rust nightly just to iterate over chunks of 3? That doesn't sound interesting to me. Okay, so we have the groups of elves already divided and everything. So I think I will just use a vector for this and do dump code. Like, it's nice that these array chunks is in Nightly and will at some point be included in the language. Like, I think it makes a lot of sense, and here I guess I will receive a fixed size array of 3, so that's pretty neat. But I don't want to be using Nightly for for this, or do I? I mean, it is quite simple. Just Rust app install Nightly, and yeah. Yeah, but now let's keep on Rust stable for now and try to do this solution without needing any Nightly things. Let's also go back here to the sample input. And what should I do then? Well, we could say let lines be a vector of something, and do. Actually, I think we will need to type this, but let's say input lines collect. And what is this? A vector lines is a vector of, yes, of string slices. Nice. We can then maybe do, instead of input lines again, to say lines iter. And this should be the same thing. But now we have like an actual vector for lines. So we can iterate these in chunks of 3, as far as I know. Lines, do you have chunks? Chunks, exact, returns an iterator over chunk size. Yes, you. So vectors know about chunking. That is pretty neat. And then we have a chunks 3, chunks of size 3. That's pretty good. We're going to sum, and we are going to receive a chunk and say something like 0. What is this chunk? This is a slice of strings. That's pretty nice. So yeah, we have this slice of strings. We can say this is the group, elf group. And now we have 3 elves. We should have 3 elves here, or 3 elves rucksacks. And we have to do the intersection between these 3. So we can do something like let's group items be elf group, not map but iterator map. You're going to map into, well, just say string as bytes, and I probably will need to collect. Do I want to do this? We already have a slice. No, I probably don't want to do this. What do I want? I want the shared thing between these 3 things. So let's express it in, say, let's badge will be the intersection. Intersection. We are going to make an like auxiliary function for this, but of group 0 and the intersection of not that intersection of elf group 1 and elf group 2, I think. And then we're gonna calculate the priority for that batch. So we can extract this into a function that is priority for item type. And here, I guess we can inline this variable. Good. What do you complain about? Well, of course, intersection that doesn't exist, so I guess that's a fair complaint. Intersection is going to take two strings. Let's say simply A. It's going to be a reference, string reference, and B, another one. And it's going to what should it return? Because it cannot return a reference. It has to like hold on to something, like allocate in somewhere. We could do that, I guess. Or we could also maybe do something very similar to this. And I think I know what I will do. Let's go back to the idea of doing very direct, like very dumb code instead of clever code. It's going to be the batch, and the batch is going to be for each item type in elf group 0. So this is going to be the first elf. We're going to see if the elf group 1 contains that item type, and the elf group 2 contains that item type. Then the batch will be that item type. And there is no batch. There should be a shared item type between the three elves. Nice. And now you can say priority for item type batch as u32. Okay, this isn't giving me any errors, I think. Or yes, it is. Yeah, elf group 0 is not an iterator, of course. And neither will it be the other ones, I think, as bytes contains this. So I guess elf group version is contained in. Interesting. Can I ask that? Item is contained in? No, but item doesn't exist. Item type exists. Is contained. Not really. So what is your problem? So it expects a function to ask this. Okay. Maybe we can do something like very, very silly code still. Let's first elf Oh, let's say elf1 is gonna be elf group 0 as bytes. So now this is not elf1, this is elf1 rucksack. Yeah, let's do then f2 and f3. It's gonna be this, and now we go for each item type in elf1 rucksack. We can ask if the elf2 rucksack contains that item type, yeah, and if the elf3 rucksack also contains that item type, and in that case the batch will be that item type, and that way we are doing very inefficiently the intersection of three sets. I guess there should be shared item type between the three elves. Sure. No shared item type between the three elves. Oh, that's the error. Actually, I prefer the previous errors. Okay, let's run. 70. Is 70 the answer for the sample code? Yes, it is. Now let's cross our fingers and run this with the full input. 2425. Submit, and yes, that was correct. Nice, very nice. And okay, the drawing is now looking like something. I don't know. Oh, this looks like some sort of river, and it's some sort of land here, and the river is entering this way, I think. But yeah, nice. We have the two answers and a bunch of code, but I don't really mind about this. Maybe we could have used sets and something more interesting, but I mean, is there a problem of doing this? I don't think it is really that bad. There's a bit of repetition here of doing like as bytes in every case. But I mean, if we do like set operations or something like that, I wouldn't be surprised if you know, you try to be clever and optimal in terms of like algorithmic complexity, but then it ends up being like slower because you're like using arrays is very memory efficient. And in this case, we are not copying anything around. Like we are always doing like slices over the input data. The only thing that we are allocating is well, the input and then this vector, but the vector is also of string slices. So you know, each line is not copied into this vector. Like this thing is, I guess I can write it down. It's a string slice pointing to an existing string piece, which is the string in the input. So we're doing very little copying. So I wouldn't be surprised if like a hash set implementation wouldn't be faster than this. And we will have to profile this and measure if it's actually faster or not. So because of that, I'm not really tempted to go and try a hash set based implementation. But we can take a look at what we wrote and see if we can make it more clear in some way. So here, for the first part, we are calculating the shared item priority sum. I guess this is a mouthful of a variable name. What is the sum of the priorities in those item types? Although, like, what the puzzle is asking for is not so different from that. The sum of the priorities of those item types. So yeah, shared item types, priority, sum. I'm good with that. Actually, I think I prefer not being so explicit here. It's just like, I don't care about the type of that. It was just to exemplify what was happening there. So we have here the rucksack items, first compartment and second. We are splitting at that. I really like that learning about this split at. So we can actually, in README, we can mention that we learned about that. Day 3. What is it called? Rucksack reorganization. So learn it about slice split at, which is very convenient for splitting things without can I write allocating. Yeah, I really like that. These kind of things in Rust are like very, very cheap abstractions. Like, yeah, you can split an existing slice and it doesn't copy the two pieces of data. It just returns you two slices, and slices are basically fat pointers. It's a pointer with a size, so it's just a very cheap data type to be copying around. So that's really nice. It's like, yeah, basically a pointer and a number. So here we have the two compartments, then shared item type, and we just do a simple for loop. I guess this for loop could be replaced by a find or something like that. So maybe we could add these things. Yes, add everything. And now let's try to see how it looks with, instead of doing this, doing first compartments, iter find. We are going to find the item type that is contained in the second compartment. Yes, and then we can break. Like, find is already like short circuiting. We don't have to do an explicit break. But if we do find something, we should unwrap, I guess. Yes, and this unwrap actually takes care of what is the shared item type. It's a reference to U8. So can we make this intuitor? I don't think I will be able to. Let's remove this. Shared item type. No, still a reference. Doesn't need to be immutable. Can I dereference it? Yes, but why is intuitor not? This makes sense. This also, I think, makes sense. Although contain shouldn't. Okay, is this still working? Yes, it is. So why does iterator not give me, like, this should give me an iterator of copies of these values, I think. Like, if I do map here, I don't know, what is A? A is a reference to U8. So I don't know what I'm missing here. No, into iter. So if it is an iterator, it's also a reference. I'm missing something here, I think. What is it though? Iter cloned. So if we clone, yeah, if we clone, A will be not a reference, but a value, and we can also ask if it contains the value. It's like a reference to the value itself. So yeah, there's something here that I still need to learn about Rust, which is like when to use cloning iterators and things like that, and when to use into iterator. So in that case, I thought that it was okay to use into iterator, but I don't know why that didn't give me like move those values. But I guess it didn't make sense to move those values because these are copyable values. Yeah, but we can, I guess, just do this and dereference. And maybe we did have a better error message before, which was something like, what was it? I don't know, because I don't. There should be a shared item type. Great. We can copy this, and we can do like, instead of unwrap, and like, what we are doing with an unwrap is basically saying, hey, I'm expecting this thing to exist, and if it doesn't, it's like raise an error or abort the program. But if that doesn't happen, and if that condition is not met, we are not going to have like a nice error message. So maybe we can show that. So in the first half, I think it was single lowercase p, the thing that was shared. So let's find p. Yeah, this p. So let's remove fp, so it's still like even number of characters. And let's run this, cargo run. Well, it didn't complain, but 159 is not the answer, I think. 157 with what? Oh no, because now there should be another. Okay, let's add instead of fp, let's say fx. I don't know. And yeah, now it panicked, and the message is not very informative. Like option and wrap panicked, and I guess you can put a backtrace. Rust backtrace, and it can tell you where it failed with a backtrace. And we can go there, I guess. Yes, but maybe it would be better to do like expect, and we are expecting this we are expecting this value because there should be a shared item type between compartments. Cool. And now if we run, well, let's run without the backtrace. Yes, there should be item type. Okay, so now in the error you have at least a bit more information of why it failed, what was the expectation. So I think I should get used to writing expect, like why I expect the value instead of just simply saying unwrap. And this also goes for things like this and all of those examples. But in this case, it was an optional, not an optional type. So in those cases, it's like being explicit of why I think it is not none and it is a present value will make the code clearer. So we can go back here and not so much back. We can run now, and yeah, it still works. Let's discard these changes. So we go back to the full input. We have the, I think that these were the correct answers, yes. And okay, and we can do, I think, the same for this part. So instead of having this giant thing and loop, we can have a similar thing. We can say F1 rucksack iterator contains no find. So we're going same thing. We're gonna find the item type that is contained in the other two. F2 rucksack. Well, basically this condition. We can copy paste, of course. Then this for is not necessary, and then the assertion, we can steal this message. Yeah, bye. And we can expect this value with this message. There should be a shared item between the three elves. Cool. And now batch is a reference. And we can dereference it, I think. Yeah. Yes. And it doesn't need to be mutable, of course. We can run. Same result. Nice. And I think let's take a look at that change. Yeah, it actually is a good change. It makes the code a bit shorter and I think more expressive of what we were trying to do. I guess we could also extract this. No, but I think no, it doesn't make sense because here we are doing an intersection between three things, and no, I don't care about like abstracting this over the case of 2 and 3. So this is fine. Disruption, yeah, I'm fine with that too. So yeah, and then what about this variable name? Group batches priority sum. Is this what we are asked for? What is the sum of the priorities of those item types? Yeah, I don't remember why the batches are as badge. Highlight all. So batches. So okay, yeah, the batches are basically the item types. Batch item type. Fine. I am good with that naming. And finally, this function priority for item type. Yeah. And this could, of course, be named simply item type. Invalid item type. Great. And yeah, I think if I go here and add some character like this when I run, why didn't it complain? Shouldn't that be an invalid item type? Like, I don't know, you do this and oh no, it's not an invalid item type because we're not sharing it between we can, I guess, do something like this. Yes, invalid item type 36. So maybe here, like, we could do something like convert this thing to char. Is there a char from U32? Converts I think I will need to have some SU32. Why don't you like this? doesn't implement display. Okay, can you show it like this? It's some la. Rust. Print U8 as ASCII getter. As char. So this is item type as char. Do you like that? Sorry. Do you like that? Yes. Invalidated item type $sign. That's pretty good. And does it have? Yeah, it also has a display. Yeah, that's pretty good. It can also be printed nicely. Unreachable code. Yes. This is good. This is good. This is a nice change over that solution, so I will just include it. I will not include this, discard it. And yes, I'm happy with this solution. I won't be refactoring a lot after this. I think it's enough bike shedding for today, and I'm okay with the general shape of this. It's actually less code than yesterday's, and I think I shouldn't overcomplicate it. So let's commit. Day 3 solution. Wait, did I have everything that I needed in the README? Yes, I think that's the only new thing that I learned or worth commenting about. So yeah, let's commit that. And was there something else worth mentioning there? I also learned that there is no stable solution for chunking. And also that there's no good solution for chunking on Rust stable release or a stable channel yet. Good solution for not just chunking, for chunking iteration, chunking iteration for iterating over solutions for chunking an iterator. Iterator on Rust stable channel yet. Good. Yeah, I think I can always do this, although I'm not sure if the GitHub Markdown formatting prints these new lines. So I think I can use this. I just get confused because I'm seeing my face over here, and it's sometimes how do you say, it sometimes blocks some part of the page, of the screen, I mean. So sorry, I'm a bit sleepy already. It's almost 12 o'clock, so I think that should be it for today. I can amend this into the previous commit and just push, and that's it. That was day 3. And tomorrow, I don't know if I will be able to do day 4 because I have a very busy day, but maybe on Monday. So see you later. Bye bye.